And that is going to be the focus entirely of chapter 4. And so last time, will you guys remind me, we did do number 2, I believe, but not number 1. So let's take a little bit of a step back and we'll kind of run through numbers 2 and 3 and so on and so forth. For number 1 says determine whether 5, negative 1 is a solution to the system. So we've done one of these at the start of every single chapter so far. We were trying to determine if something really is a solution. So could you guys sum it up? Like if you're trying to check to see if something is a solution, can you say it in 3 words? How do you determine if something really is a solution to a, yes?
Plug it in.
Plug it in, right? 3 words, perfect. So if we are going to check to see if 5, negative 1 is a solution, we need to plug it into both equations, and it needs to work in both equations in order for it to be a solution. If it works in one, but not the other, it's not a solution to the system. If it works in neither of them, and of course it's not a solution, it's got to work in both. So let's plug in. Let's see what happens. I'll just plug into the first one because it's the first one. 2 parentheses negative 5 plus negative 1 equals 11, possibly equals 11. So when you do your order of operations, we do the multiplication first, right? So you end up with 10 plus negative 1 equals 11. What's the issue here?
That's false.
The left side is 9, right? And 9 definitely does not equal 11. So what conclusion would you have to write for this?
Nope. It's not a solution.
It's not a solution, yeah. So you'd come over here and say 5, bless you, negative 1 is not a solution for the system. And we didn't even have to try it on the other one because on the first one we tried, it didn't work. And so since it didn't work on the first one, it is not a solution to the system. Okay, do you guys have any questions? This should feel really familiar, right? Because we've done this. I think this is the 4th time we've done this in class. Okay, awesome. Take a look at number 2 then. This is the one we did last time. I thought we could kind of review this and kind of get to the main points here. It does say solve the system by graphing. So can anybody explain what we would do here? What did we do last time? Yeah, Avery. Okay, we put them into slope-intercept form, right? So for the first one, slope-intercept form was y equals negative x minus 4. And for the other one, we had to do a little bit of work, right? We had to subtract x and divide by negative 2. I think this one ended up being y equals, let's see here, 1/2 x minus 1. You guys have that down for this? This is the one we did last time. That's why I'm kind of going fast through the steps. You can go back and confirm if you want, but we did this last time, so I thought I'd go quickly. So for the blue line, Joel, what is the y-intercept?
The y-intercept for the blue line is 0, negative 4.
That is correct. So let's see here. 0, negative 4 is right there. And according to this, it's got a slope of, anybody?
Negative 1.
Negative 1 is the slope. All right, so let's see here. If I, this means up 1, left 1, or down 1, right 1. So we're going to follow these points right here. Just a reminder for your quiz coming up here in a little bit. If you are going to be using the slope to graph a line, make sure that you are putting in those little slope marks. Okay, so there's the blue line. And then the red line is a little bit different. Grace, what is the y-intercept of the red line?
Negative 1.
That's right. So the y-intercept is 0, negative 1, so that's right there. And then, Victoria, what is the slope of the red line?
Slope of the red line, 1/2.
Yep, so we're going to go up 1, right 2, or we could go down 1, left 2, and therein lies the key to doing this question. You guys remember from last time, Graphically speaking, what is the solution to a system of equations? This is where we finished last time. Will's got the hand motion down. Where the lines cross, right? Where the lines intersect, that's the solution. So you can see it right there. That's where the two lines cross. And so we got to figure out what the coordinates are for that. So would you try? What are the coordinates for that point of intersection? -2, -2. So that would be your solution right there. We arrived at that solution by graphing. We found the intersection point, -2, -2, and we're done. Does that work? Questions? Do you have a question, Jose?
No, I got it. No.
Are you sure?
Yes. Because I was so confused on the negative x, which would be 1. It's a,
So it's -1x, right? Yeah. Anybody else with a question? Fantastic. I want you guys to try to use the same kind of reasoning to try number 3. Ready, set, go.
Okay.
Look at these flaws.
Are done. I did not find my way around to everybody. So do ask questions if something does not make sense. The first equation is already in slope-intercept form, right? It's already there. And so I've had like 2 or 3 questions about like, what on earth do I do with that second line? So this is going to be a really good skill for you in the next 15 or 20 minutes, something we practiced in chapter 2 and 3. Don't we need to solve for y? We need to put it into slope-intercept form. And right now the y is not by itself. Isn't there a -2 that's with the y and an x? So a really important question that you've got to get figured out right now is, I got to get rid of the x and the -2, right? I got to get rid of both of them to get the y by itself. Which one do I get rid of first? You have to get rid of the x first. That's too strong. You don't have to, but it's very, very much better for you to get rid of the x first. So it's a positive x. And so how do I get rid of a positive x? So I'm going to go -x from both sides. When I do that, these x's over here add out. So it's gone. That was kind of the point. I'm left with -2y equals. What do I do with that 4 minus x? Can I combine those into just being like a -4x?
No, you just do 4 take away x.
Why not?
Because they're not like terms.
They're not like terms. That's right. So I can't do that. So 4 minus x just goes right there. Then finally, I do have to also get rid of the -2. How's the -2 attached to the y? So I need to divide. Yeah, division is correct. So dividing by -2, I would do it like this, Cole, which is a little bit different than your notation. That'll allow me to see y equals a positive over a negative is a negative, so that's -2. And on the right side, isn't that really technically a 1x or a -1x?
Yeah.
And so a negative over a negative is a positive, so it's plus 1/2 x. So now I've got this first equation in slope-intercept form. Now I've got the second equation in slope-intercept form. Now I'm ready to graph. That make sense? Okay, so here is line number 1. I'm going to call this one line number 1. What is the y-intercept on line number 1? Seems like it's not there, and it's 0, whoever said that, right? Isn't it y equals mx plus b, and up there it's like mx plus nothing? That means your y-intercept is 0. So 0, y-intercept goes right there, and the slope is up 1, over 2, up 1, right 2, and then up or down 1, left 2. And so that line could look like that right there. I don't know if you guys have figured this out yet. The other line's kind of interesting. What's the y-intercept on the other line? Line number 2. Okay, so -2, so that would be right there. And what's the slope on that line? 1/2. Also 1/2. So we go up 1, right 2, or we could go down 1, left 2. So
Parallel.
what's the deal? Yeah. The lines are parallel. So remember, what is the solution to a system of equations? Guys, listen, there's a little bit of logic I want you to get here. What's the solution to a system of equations? Where the lines intersect, where the lines cross. So parallel lines, where are these lines going to intersect? Nowhere. So what's the solution? There is no solution. The lines will never intersect, so there is no solution on that one.
You just write the lines are parallel.
Well, it wants to know what the solution is, so if you just say the lines are parallel, you're like one step away. Like, it's like me saying, hey, did we win the game? And you're like, well, we did score a basket. Yeah, but what does that mean, right? Did we score the winning basket or what? You know, does it make sense?
Yeah.
Okay. Hey, did anybody see this really early? Did anybody look at these two lines and say, look, same slope, different y-intercepts, they're parallel, right? If you see that, we'll talk about that here in a second. You can actually see that early and you can make that call right away. Okay. There is a little bit of a summary down here that I just want to briefly go over. There are three ways that two lines can interact. The first one we've looked at, that is right here. That is where the two lines intersect in one point. That was like the first one we did. And this is like the second one we did, where the lines are parallel. They never cross, so there's no solution. And then the last one is that you have two identical lines. How many points of intersection would those two lines have if they're the same line?
Infinite.
Infinitely many. Wouldn't they be right on top of each other? So that one would have infinitely many solutions there. But we did look at the first two. I figured the first two were the more interesting of the two. I suppose that's debatable, but we looked at those two. All right, so this kind of leads me to the final thing that I was just talking about there with Jake saying that maybe I saw that kind of before we graphed it. You can actually determine how many solutions a system has without even graphing it. You simply have got to put both lines into blank form. Slope-intercept form. That's right. And then check out the slopes and the y-intercepts. That will tell you all you need to know about how many solutions it has. And so I thought we could do a practice one like that. Check this one out. Number 4. So check out number 4. I want to do this one with you. Please notice what this question does and doesn't ask. Do you see how it does not ask for the solution? It just wants to know how many solutions there are. So we just want to know, hey, is there going to be one solution, maybe no solution, or infinitely many? We just want to answer that question. We don't have to actually find a solution for this. So here we go. We're going to take both of these lines. This is going to be excellent practice based on the questions that I was just asked. We're going to put both of these lines into slope-intercept form. So let's hear how to do that. The top one, Carissa, the 2x plus 3y equals 6. What would need to be my first step to put that into slope-intercept form?
Subtract 2x.
Please listen. Subtract the 2x. Agreed. So, Carissa, when I do subtract the 2x, what results?
3y equals 6 negative 2x.
That's exactly right. Paige, what do we need to do to finish this one up and get all the way to slope-intercept form?
Divide by 3 plus times.
Fantastic idea. So when I divide by 3, I get y equals 2 minus 2/3 x. So what's the slope on that line?
2.
And the y-intercept is 2. Okay, so we got that one done. Let's go ahead and work on the other one. This one is 7x plus 5y equals negative 10. I hope this is starting to click for you. Cooper, what do I have to do in order to start the ball rolling towards solving for y?
You gotta get rid of the x, so it would be 7x minus, and then you put it on the other side.
Okay, so we're going to subtract that over. So when I subtract that over, Cooper, what results from that process of subtracting?
Negative 10 minus 7x.
And what about the left side of the equation?
You did? Really? I had a good one too.
In order to make this judgment, Jake, what form do we need to be in on both lines? Slope-intercept. So I'm going to take this top line here, 2x plus y is equal to 4, and I want to put this into slope-intercept form. Sam, it's currently not in slope-intercept form. What do I need to do to get it there?
Get y alone, so you have to divide 2x, or, yeah, right? Subtract 2.
I'm just listening. What do you think? You listed out like 3 things to do. 2 things? Okay. Which one do you think is right?
Subtract 2x?
So let's see what happens if I do that. So if I subtract 2x, Sam, are these like terms or not like terms? They are like terms. And what is 2x minus 2x?
They cancel out.
They do. And that was our goal, wasn't it?
Yeah.
What about on the right side? Are those like terms?
No.
So what do I write if I have y equals the right side?
Y equals 4 minus 2.
That's exactly right. And that's in slope-intercept form, right? Give me some. Sam? That's in slope-intercept form?
Yeah.
Cool. All right. So then, Lana, what about the other one? The other one will take a little bit more work. 3y, I don't know, that's debatable, equals negative 6x plus 12. Like Sam, we want to get the y by itself. What do I need to do?
Just divide the 3.
Divide by 3. Good. So if I divide both sides by 3, gentlemen, quiet down, please. Thank you. Y equals, what about the negative 6 over 3, Lana?
There's an, oh, you divide that and you get negative 2.
Okay, so negative 2x. What about 12 over 3?
You would get 4.
Okay. So then we look at this. Alec, what do you notice about the two equations?
They are similar if you move the singular, you move it around.
So what do you mean by move them around?
So like if you were to like flip-flop forward 2 on like one of them,
So tell me exactly what to write, on the red one or the blue one?
we'll do the blue one.
Okay, so what should I do with the blue one?
Y equals 4 minus 2x.
You guys remember that idea that as long as you keep the sign in front of the term with the term, you can rearrange like Alex suggests? So then once you see that, Cole, what do you notice about the two lines?
They're like similar.
I think we could use a stronger word than similar, right?
They're the same.
They're the same, right? They're exactly the same. I agree. So if the two lines are the same, if we were to graph them, what would it look like?
One line.
One line. Wouldn't the lines be on top of each other? So how many solutions, Avery, does this system have? Yeah. So here's your conclusion. Infinitely many solutions. Oops. There we go.
Can they just stay the same and make it parallel?
Well, so parallel lines are a little bit different, right? So parallel lines